All right, recording is rolling. Welcome to Thursday, September 7th. We're gonna go outside today, not immediately right now. I'm gonna remind you guys what we're doing. So yesterday I showed you guys how to use the launcher equipment. It's all on your desk. Guys, what are you guys gonna do first? Are you going to put the squishy ball on first, or are you gonna ramrod it first? Yeah, ramrod it first, put the squishy ball in afterwards. Otherwise the ball gets stuck. Okay. And your question today is, what is the launch speed of this launcher? There's different techniques you can use to find it. I'm going to kind of streamline this. So we'll all be using the same technique. And the technique we're going to all use is we're going to be on the balcony. There's some height drop, okay? And we're all going to blast it horizontally. Okay, that's the procedure. This lab's going to be much simpler than the previous lab. There's no independent variable going on. You can do a couple of shots, or probably a few shots, right? To maybe like reduce random error, experimental error, right? They'll probably land approximately the same location, horizontal displacement. Okay. All right. So before I dig into that too much, some reminders, what's going on this week. Guys, tomorrow, AP Classroom Unit 1, you guys will have finished by tonight so that tomorrow I can go over those solutions in class. Okay. And your linear motion take-home quiz. Everybody does have a linear motion take-home quiz, right? Oh. Right? You guys got that? Right. Then Monday, your chapter 3 puzzles. These are all projectiles except for one of them. I'd ideally like to, by the end of class today, also go over the non-projectile one. So I really hope I have time in class to do that with you guys today. You guys were school photographs on Monday. Right, so you guys got either some paper out or you guys got your lab notebooks out. So you guys are writing this write-up. I'm going to pick up this. I'll have you guys turn this into the grade tray by the end of class today so I can check the talk, get you guys points. So this 5-part write-up. I'm helping you guys out. I started it off for you guys. We all have the same question here.
Good morning. Sorry for the interruption. Mr. Roach coming to you live from Mr. Grader's first period.
All right, recording, resume. Right, yeah, so everybody's individually doing this write-up. Paper? Here. All right, pretty good. All right, so we all have the same question. What is the launch speed of the projectile launcher? I showed you guys how to operate that yesterday. Right, now these are your only measuring tools. Well, the scale I took care of for you. I showed you guys the digital scale, the triple beam balance. I went ahead and measured the mass of the ball for you. Let's just treat that as a control. The main tool you guys get to use is a meter stick. Right, you guys see the meter sticks on your desk? Oh, there's also some trundle wheels. Right, you guys ever use a trundle wheel? You get to try it out today if you like. Right? I've got 7 trundle wheels. There's 18, so got what I got. Right. And so procedure. The procedure is just a handful of steps. Usually AP is looking for 5 to 7 steps. I set up the first couple steps for you guys. Okay. Set up the launcher aimed horizontally from the top of the balcony. Boom. That's the entire lab setup. Boom. There you go. Right. That's simple. Just in a nutshell, one sentence. Boom. Right. If this was an AP FRQ that you got in May, that's exactly what they'd be looking for. Right. Set up the launcher aimed horizontally from the edge of a balcony. Boom. Okay. Then you start using these measuring tools to measure certain things. You want to write as a sentence, use the scale to measure the mass of the ball. Mass of the ball, by the way, is 6.3 grams. I'll go ahead and give it to you. Okay. Do you guys imagine if you had different mass balls, they'd probably be fired different distances? Do you guys think? Right. Yeah. That's sort of a future material, but yeah, maybe just keep that in the back of your mind now. For today, we're just using the constant mass, 6.3 grams. Okay. Whatever. Right. Ooh, I bet I have to measure some other things. What are some other things do you think you have to measure? Use the meter stick to measure the height of the balcony. Use the meter stick also to measure the horizontal displacement that the ball lands, right? You can spot where it lands, right? Or maybe the trundle wheel, if you like. Right? Right, so you're gathering data. I'm using this tool to measure this. Use this tool to measure this. Right? You're allowed to know the gravity field is your preference, either 9.8 or 10 meters per second squared. Okay? The analysis for this lab, a lot of times it takes the form of graphs, but today it's just going to be equations, just kinematic equations. Okay, kinematic equations. Okay, so you have the 3 main kinematic equations. Oh. These guys right here, these 3 amigos. How can you possibly use these to ultimately figure out what is the launch speed of the launcher? Now, this is a projectile, so this is going to be a process type problem, right? Actually, I showed you guys the process yesterday. I kind of revealed the process answer. Okay? And your conclusion. The blast speed is so many meters per second, right? Because that would answer the question, right? You guys see that? Right? You guys see that nice outline right there? Okay. You guys got written down at least what I got written down so far? Because I'm giving you guys a head start with that write-up, right? Okay. Yeah, if you need to real fast. Guys get so far? Okay. Now, that paper is pretty filled, but here, I'll show you guys the honors version real fast just because I was able to fit the table on it. Okay. This is a table I might make. Trial, 1, 2, 3. What's the height? Just a constant number all the way down. What's the horizontal displacement? Which would be approximately the same number all the way down. I don't expect it to be like wildly different, right? Maybe plus or minus a few centimeters, right? Right? Guys think? Right? That could be the entire table. Yeah, there's no independent variable in this one. You're just gonna blast it a few times to see where does the ball land, and then run those kinematic equations and figure out what is the launch speed. Right. Great. Are we good so far? All right, you guys ready to head outside on balcony? All right. Again, yeah, let's do approximately 3 launches, and then I'm gonna come back. I'm gonna walk you guys over the AP solution. Right, I'll walk you guys through the AP solution, AP style solution, and then I really hope that there's some class time left so I can do some more textbook puzzles with you guys. All right, let's stop that recording and head outside.